We have a war on our hands, people. A war that has been going on for years, happening in our electrical devices. We call it Ohm's War. The war consists of 3 different armies, each with their own motto derived from the one formula, V equals IR. This formula is known as Ohm's Law. Unfortunately, only one of the armies, known as the Resistance, has actually taken out the time to talk to us today. Thank you, George. It's a pleasure having you here. So, Mr. Ohm, please tell me about your army.
Thanks, class, for having me here today. Our motto is resistance equals voltage over current. As you can see, the resistance tries to stop the current from growing. As the formula suggests, the greater the current, the lower the resistance. Therefore, this war is based on survival. As resistance and current clash, the third army, known as voltage, appears. For a circuit to work, a voltage must be present, and without a voltage, our clashes with current would be pointless. Therefore, voltage is always present in electrical circuits. As resistors clash with current in electrical circuits, voltage is dropped across it. This allows resistors to control the amount of voltage available to be used by the rest of the circuit. This example circuit shows us that there is more voltage across a component with a high resistance and a constant current.
Here, we are demonstrating how we can determine the voltage across a resistor. In this case, R1 and R2. To do this, we simply use Ohm's law, V equals IR. Therefore, the resistor and current values are subbed into the equation. This will give you the voltage across each resistor.
The second circuit shows how one can find a resistance value using Ohm's law.
To find a resistance value, you simply rearrange Ohm's law. This is rearranged to R equals V over I. You then sub the voltage and current values into the equation, resulting in the resistor's exact value. Thank you very much for your time, Mr. Ohm. You have genuinely made it easier for people to understand resistance.
Thanks, Lee. Anytime.
And there it is, ladies and gentlemen, an explanation to Ohm's Law from the Resistance.